Welcome to Notebook 34, Chain of Thought Prompting. In this notebook, you're going to learn about one of the most famous prompting techniques called Chain of Thought Prompting. By the time you complete this notebook, you'll learn Chain of Thought Prompting, and you'll also encounter and appreciate something called Large Language Model Hallucination. This notebook is a little bit of a departure from our explicit use of message types. You'll see we won't be learning any new kinds of message types and making a point to exploit them in particularly novel ways in this notebook. But we think that the chain of thought prompting technique is well within context of this section, so we decided to include it here. To begin, we'll make some imports, nothing new here, and also nothing new here, instantiate our LLM instance. Okay, so we're going to make a claim that large language models jump to conclusions. So since LLMs are primarily designed to generate what is most likely to come next in a stream of text, it's no surprise that they can often, quote unquote, jump to conclusions in scenarios that in fact require complex reasoning. So consider the following example, which challenges the large language model to do some multiplication. So before invoking the LLM, we're going to use Python to do a little math for us. So we've got 345 times 888, which is 306,360. And then now we're going to ask the large language model, hey, what is 345 asterisks, which we intend to mean times 888. And you can see that we got a response here, 306,720. So this answer is incorrect, straight up. But given what we know about large language models, again, that they're designed primarily to generate the most likely response, given the data they were trained on, it might not actually come as a surprise that it did this. Significant changes in coming years, as we've already seen in recent years, are likely to come, but as it stands, and in spite of the common use of terms like artificial intelligence, large language models, in fact, are just not really well suited, at least not without additional user support, to do deliberative step-by-step reasoning. Rather, as we know about LLMs, because of their design, which is to generate what it expects to come next, they're actually very well suited, and this is kind of their intended purpose, to jump to conclusions, right, and provide what ought to come next. So this phenomenon of LLMs generating incorrect information, often with what appears to the end user like confidence, we call this hallucination. And again, because of their design, an LLM will typically say something incorrect. We'll say unbeknownst to the LLM itself, not that there's any like meta awareness or reasoning capability behind it, right? But like it's just doing what it knows how to do. But it will usually say something incorrect rather than say nothing at all, right? Even if it's not well suited to give an answer, it will rather say something incorrect than say nothing at all. And while it's true, right, that large language models over time are definitely hallucinating less, and that over time they're going to continue to improve in this regard, hallucination, again, because of their nature, it's an inherent characteristic of large language model generation. So regarding hallucination, please commit the following two golden rules to memory. One, you should assume that all LLMs will hallucinate. And two, you're the one who's responsible, right, for what your LLMs generate in your applications. Okay, I mean, if you're using an LLM for your own personal reasons, kind of whatever, but as someone who might be designing applications or taking care that your applications are serving your customers, right? When you think about what your customers need, what they expect, etc., you definitely need to put some thought into when and how an LLM might hallucinate, right? And take that into account when you develop your applications. Okay, so returning to the main subject matter of this notebook, while LLMs are not in fact well suited to long-form deliberative reasoning, there are some techniques that we can utilize to guide LLMs towards taking a more deliberate step-by-step approach when the task demands it. And one such technique is called chain of thought, or COT. This idea was formalized in 2023. There's a link to a paper here if you're interested in drilling in more to it. And chain of thought prompting is still one of the most popular prompting techniques, especially in situations that require some step-by-step reasoning. And it supports complex reasoning capabilities by encouraging LLMs to break down complex problems into intermediate steps. Chain of thought prompting involves providing examples, typically, that demonstrate step-by-step reasoning to solve a problem. If you drill into that paper, you'll see this example. We have an approach here where we've got a word problem, and you can see this is a little bit of few-shot prompting here. We're giving the model a question, we're giving it a response as an example, right? And in the example, we simply give the response. The answer is 11. Now this is the correct answer, but all we give the model an example of is answering the question directly. And then when we prompt the model, right, with a different word problem, In this case, in the paper, the model answered with 27, which is not the correct answer, right? Now, in chain of thought prompting, in the way that this paper explores it, same thing, we give the same word problem as a question, but now in our example response, rather than providing an example where the model answers the question directly, you can see that we provide an example where the model has given a response that actually breaks down the process into several smaller steps, right? And then arrives at an answer only after breaking down the process into smaller steps. And then again, in this example in the paper, given the same word problem that with what they're calling standard prompting failed to get correct, you can see now the model generated an output where instead of answering the question directly, and in this case incorrectly, it took the time to take the word problem and break it down into some subsequent steps. And in doing this more step-by-step approach, was able to arrive at the correct answer, which in this situation was 9. Okay, so let's explore this more directly in our environment, and we're going to try it with a 3-digit multiplication problem. We saw above, if we just scroll up here for a moment, that we tried 3-digit multiplication with our current model earlier, and it was kind of sort of close, but definitely got it incorrect. So now we're going to try again, and we're going to do this using few-shot prompting. We're only going to give one example prompt. But in this case, for our few-shot prompt, we're going to start with an example problem. What is 678 times 789? And now we're going to provide a chain of thought example of working through the problem step by step. And as you can see, this example is quite lengthy, but let me break this down into steps. First, I'll break 789 into hundreds, tens, and ones. I'm not going to read through this entire thing. You can if you want, but you can see we're really going out of our way to take a somewhat complicated math problem and break it into small steps, where each of the small steps, we assume that the large language model is actually up for accomplishing these individual steps, right? Even if it can't do the larger problem in one go. Now that we have an example problem and an example chain of thought response, we're going to create a chat prompt template using from messages to do a one-shot prompt template where we give the example problem and we give the example chain of thought response from the AI, and then we complete our prompt template by parameterizing a long multiplication prompt. We're going to create a simple chain that we'll call multiplication chain, and now revisiting again 345 times 888, which we did earlier. Okay, we can tell already that the model is generating more text. It took a couple seconds, and you can see following the example that we provided in our one-shot prompt, it broke this down into many steps, and it gave this time that the final answer is 306,360, which in fact is the correct answer for 3-problem multiplication, as we can see with this simple Python code. So all that to be said, by using chain of thought prompting, we were able to take a model that was unable with a very naive prompt to do 3-digit multiplication and give it the opportunity to tackle the problem in smaller steps, reason about the process, and in this situation come up with the correct answer. Okay, now kind of a cousin technique, called zero-shot chain of thought prompting. As you can see, chain of thought prompting can get really verbose. And as we mentioned a couple of times now, you really shouldn't be shy about writing long prompts that are very specific and very verbose when you need to accomplish your goals, right? There's no reason not to. But that said, there are some elegant ways to leverage chain of thought methods with large language models. And one such method is called zero-shot chain of thought. There's also a paper that was written about this that you can drill into if you're interested. This prompting technique simply adds the following quote, "Let's think step by step," to the prompt without actually supplying a very verbose chain of thought example or examples. And in fact, it's been shown to work quite well. So let's construct a new prompt. And this time we're going to try this zero-shot chain of thought prompt on long multiplication, following the example in the paper by simply supplying the language, "Let's think step by step." Okay, so here's our zero-shot chain of thought prompt template. We're going to pass in a single human message, which is whatever the long multiplication prompt is, and then follow it up with, "Let's think step by step." Right? Pretty straightforward. We'll construct a chain out of this. And now let's try it again with 345 times 888. And you can see that similar to providing an example to the model to reason about it step by simply specifying to the model that it ought to think about it step by step. In fact, it went ahead and did that. And once again, when it was able to be compelled to think about it step by step, doing 3-digit multiplication was no problem for it. And you can see it's 306,360 was again the correct response. So let's talk about chain of thought prompting in practice. As with many other aspects of prompt engineering, especially given the variety of large language models available, both now and in the future, when they're probably going to be getting better, I want to continue to emphasize that it's really difficult to give hard and fast rules about when and how exactly to employ chain of thought prompting. Like in both of the papers that we link to in this particular notebook, you can see evidence of these techniques working well, right? So it's taking nothing away from that, but we always have to remember that these were done with specific models of specific sizes, right? Specific generations of models. And we're just in a world right now with large language models where things are changing a lot. And even if they're not changing in terms of quality, like the differences between one model and a different model can be drastic, right? So as much as we would love to have like a bunch of magic bullets in the form of like precise language that we can use, as we've kind of demonstrated in this notebook, in my opinion, right, like those are helpful to help explore possibilities for how we can engineer prompts, but always, always, always we have to take the time to test them out on our own and always be open to coming up with variations or our own ideas for how best to prompt our models. Okay, so, per usual, when we talk about chain of thought prompting, always develop your prompts iteratively. Start simple, try zero-shot chain of thought to begin with because it's just so easy and it's so powerful. And then if chain of thought prompting or zero-shot chain of thought prompting isn't working well for you, consider expanding and using more verbose examples like we did earlier in the notebook. And also, we're going to talk about this in a following section, but for tasks where you're finding the large language model isn't particularly well suited, right? For example, math, especially if we get more complicated than 3-digit multiplication in this case, you really might consider the use of external non-large language model tools for tasks that large language models may not be well suited for, right? Like we have the entire world of programming at our disposal to use in our applications, right? We don't want to fall into a trap that like, just because we're building an application with a large language model, we should use the large language model for all the functionality that our application needs. That would be a mistake. So just remember like to consider using non-LLM tools when they're more appropriate. We're going to explore some elegant ways to leverage non-LLM tools in the context of large language model generation like later in the workshop. But the old adage, like if you have a hammer, everything looks like a nail. Just remember, LLMs are a very powerful tool, but they're one of your many tools to use when building applications, even if the application is relying heavily or even primarily on the use of a large language model. Okay, so we've got an exercise for you in this notebook, which is where you're going to try to craft a prompt that will allow a large language model to solve a word problem that we're going to provide you. So here is a word problem, and before you begin your actual work, we went ahead and kind of thought through this problem ourselves and given you a solution. The actual answer to the problem is 288, and you can see how we reasoned about it. See if you can construct a prompt using some form of chain of thought prompting, and see if you can get our Llama 3.1 8 billion parameter instruct model to answer this one correctly as well. Pause the video, and when you're done with the exercise, come on back and we'll take a look at the solution together. Okay, hopefully you were successful at this exercise. Per usual, there's many ways you could have approached this. In our case, we opted to work with a system message encouraging the LLM to always break down their work into smaller tasks and show their work. And then we went ahead and used the canonical zero-shot chain of thought prompt as an appendix to whatever incoming prompt the user was providing. So here's our system message. You're an expert word problem solver. You always break your problem down into smaller tasks and show your work. And then in our human prompt, we provide our prompt. We went ahead and used some white space and then said, let's think step by step. Right? And in this situation, if we create a chain out of this template, you can see we can invoke it with the word problem we supplied above. The correct answer should be 288. Again, we won't read this entire thing, but the model did a good job of breaking this down into many smaller tasks and going step by step. It looks like at the end, the model was correctly able to ascertain that the answer was 288 minutes. So to summarize, in this notebook, you got to experience LLM hallucination. Hopefully you had a chance and enjoyed reflecting on how hallucination makes a lot of sense given how LLMs are constructed and what they're designed to do. In addition, you learned several different ways to approach chain of thought prompting techniques to assist LLMs in performing tasks that require step-by-step reasoning. In the next notebook, the final notebook of this section, we're going to leverage explicit message use to create a simple chatbot. And it's going to be a lot of fun. So we'll see you there.